Hello and welcome. Today we're going to be resuming the Advent of Code optimizations that we've been doing for the... Alright, I guess we did the last stream and then a couple of streams ago. We're on day 8 of 2015. And yeah, that's pretty much it. So we're going to pick up where we left off. So last time we finished day 8. I think we ended up getting this down to like 300 microseconds. Actually, sorry, I need to check one thing really quickly and I will be right back. Okay, we're back. Sorry about that. Yeah, so we did this in about 300 microseconds. Yeah, that's the general goal. So, general rules are we solve the problem, solve the puzzle, and then after that, dedicate like 10 or 15 minutes, generally 10, and then like if we come up with an idea to optimize it a little bit or something and we run over time, then that's okay. But generally no more than 15 or 20 minutes per puzzle. And then at that point, we kind of take what we have and we move on to the next one. So yeah, let's get started on number 9. Day 9, all in a single night. Actually, before we read this, let's set up our environment a little bit. So copy the template to day 9. And then let's edit the toml and add day 9. So day 9. And then let's input day9.txt and do all of this. Nope, not that. We don't need the URL, we need the content. So that Faerun to Tristram equals 65. This feels like a weighted graph. Okay, I think we might be doing some sort of pathfinding algorithm. Let's see. Every year, Santa manages to deliver all of his presents in a single night. This year, however, he has some new locations to visit. His elves have provided him the distances between every pair of locations. He can start at the end. He can start and end at any two different locations he wants, but he must visit each location exactly once. What is the shortest distance he can travel to achieve this? Okay. Yeah, I'm very graph theoretic. For example, given the following distances, the possible routes are therefore Dublin to Dublin to London to Belfast. How? Wait, Dublin to London and London to Dublin. So I guess this is like not directional. Okay. Shortest of these is this, and so the answer is 605 in this example. What is the distance of the shortest route? Huh. And our input is this. So I guess first up, let's parse this. How do we parse this? Like what is our target data structure here? So I guess like the simplest way, there's a term. I'm not well brushed up on my data structures and algorithms. Basically you have a map from key to whatever the destination is, and this holds just the list of the destinations and their weights. That seems like the simplest solution. Just to hold on to this, I guess not even a digraph, it's just a graph. Yeah, okay, sure, let's do that. So day 9. Input.lines.map Faerun to Tristram is 65. So it's going to be L. I guess we can just split on white space. we kind of know what everything is. So we can say L.split white space, although that requires an allocation. Or I guess it really doesn't. So split white space gives us back an iterator. We know that the source is iter next unwrap. We can skip. I guess we can do this as like an assertion. New keyboard can't type. Typing is hard. Typing is the hardest thing I'll ever do in life. Okay, and then we can say let destination is iter next unwrap. And then we have an equals sign. So we can copy this again. And then finally we have the wait, which we can then say wait.parse.unwrap. And I think that can just be like a U8. Okay, then we can, what's a good way to map this? So we have like Faerun to Tristram. I hope I'm saying that correctly. But we don't have Tristram to Faerun. But this seems to take these in both directions because we can go from Dublin to London. So we can't just map this into like tuple. I think we actually have to add a map. And then we can say map.insert from source to destination has this weight. And then from, yeah, you're right, DST. Then from DST to SRC, we have this weight. And then this isn't even a map anymore. This is just a for each. Let's do let, or for L in that. Okay, consider returning a value here. That is fine. We can ignore that. And then I want to just debug this map and see what's in here. Okay, the iterator needs to be mute. Yep. Irrefutable pattern. Yeah, because I copied the wrong thing. That's fine. Great. Now, if we cargo R this binary, we should get something. That feels incorrect. Oh, because we need to use like a vector here. So it's gonna be map.entry source or default dot push dst weight. And then so it doesn't know what default is yet, which is fine. We'll add that in just a minute. Also, it's going to be annoying because this is a reference to a string, but I think it's okay for these keys to be ref strs. I don't know if it can do that. Okay, it can. That's kind of nice that it can elide this type from all the way down here. But yeah, so now we actually have, what did I just do? Oh. Oh, no, do not write to that. Cargo R bin day 9. Great. So this looks a little bit more correct. Let's grab that example. So input day 9 example. That's this guy. And then what? Yeah, we need to change this down here. Great. Positive overflow. Wait. Oh. Okay, that's really interesting. So for the actual inputs, we don't go above like 150. But for this, we get much bigger numbers. That's fine. We don't need to really do U8s. U16. So we get Dublin and Belfast from London. So London can get to Belfast. Dublin can get to Belfast. Or wait, no, London to Dublin and London to Belfast. So London to Dublin and London to Belfast. Okay. We get Dublin to London, Dublin to London, and Dublin to Belfast. No, Dublin to Belfast. Okay. And then Belfast to London. And Belfast to Dublin. Cool. So we do have all of our edges, I guess, in here. Now we have to figure out how to traverse this. I mean, this honestly just feels like a traveling salesman problem, but I feel like that is unlikely. Because I feel at this point with this many edges, that's a lot. The shortest distance he can travel to hit every location once. Traveling salesman. That is really small. Blah, blah, blah. Ask the following question. Given a list of cities and the distances between each pair of cities, what is the shortest possible route that visits each city exactly once and returns to the origin city? It does. So this problem doesn't include returns to the origin city, but I don't know that that's like an important part of this. I guess how many points? So like the issue with traveling salesman is that it goes up like exponentially, but we don't even have that many points. We've got 1, 2, 3, 4, 5, 6, 7. Is that correct? 1, 2, 3, 4, 5, 6, 7. So everything connects to everything. That's an interesting thing. It's like a fully connected graph. That's actually kind of weird. Also, we have 8. This arbor doesn't exist on the left side. Interesting. I mean, let's honestly just try like the naive approach and see what it does. Okay, so we have our map, which is like a lookup table. From the source to a destination, and then it provides the weight. Maybe actually instead of even doing this, we do a hash map inside of a hash map, or we do it like a it's been a while since I've taken like an actual proper data structures thing. There's like multiple ways to represent a graph. You can either have a table between like a grid, I guess, where you have each point. I don't know what I'm saying. Let's try this. Let's do a tuple, an adjacency matrix. Yes, that is the term. That is the exact thing that I'm trying to say, but words are failing me. We can do an adjacency matrix, and we can do that easily using a hash map. Since we have string keys, yeah, that should be fine. So we can have basically source is this and destination is this. No, I take that back. That's a bad idea because then we can't look up possible destinations. No, we're going to do a hash map of hash maps. Stir to a hash map of stir U16. Like that. And so this way we can do insert, these values. Like that. And so we get London to Dublin is that. But then from here, we can say London dot keys and then get the possible targets. Possible destinations, not targets. I think it's questionable to consider a city a target. Okay. Cool. Computing a solution. Wow, there's a lot of stuff in here. I mean, I guess it's not really. These look familiar. I think I've done something with traveling salesman in the past. Oh, I did. Implemented a paper called Ant Colony Optimization once. That was fun. I'm gonna grab my tablet and get that set up. So, just 1 second. Okay, that was arguably more than 1 second, but we have a tablet, theoretically, connected. Or not. Come on. No. I think it's broken. Maybe not. There we go. Woohoo. Okay, cool. Then let's do, my paint is still broken, I think. Krita then. Very well. Okay, new image. Do I have to set the background color again? I do not. Very, very nice. Do we have, I don't know, that works. Okay. So we have points. Like so. It doesn't really matter what these points are. We know that we are fully connected. That did not really work well. I think there's a tool for drawing like a straight line. That's not it. Hold on. Let's. Oh, that changes the size. Bear with me. I'm learning Krita. I've never used it before. Okay, we'll just use the line drawing tool. So from here to here. From here to here. From here to here. Here to here. Then this one connects to every point as well. Okay, and then this one connects to every point as well. And then finally these guys are connected. And we end up with, I guess, a pentagram. Cool. And then we're going to start off at 1 point. And we need to go through every single point. So I'm thinking we basically just recursively go over every single thing. So we have this one guy, this one, not necessarily core or anything, but like one step of the iteration is going to go for this guy, and then this guy, and then this guy, and then this guy. And then from here, we have basically another round. Yes, thank you. I worked really hard on drawing this. I'm glad it meets your standards. Then we're going to go from here, and we're going to go to this guy, this guy, this guy, and then this guy is going to go to here, here, here. We do need to make sure that we don't go back to something we've already visited. So we need to keep track of who we visited and the order in which we visited them. That feels kind of like bad though. Right? Like, I don't know. It just feels wrong to exhaustively visit everybody. I mean, we can keep like a global minimum length. Like that's all it wants, right? Is the shortest distance. And so we can keep a global minimum, and then if we're walking along a path that has that is more costly than that, then we don't continue that as like an optimization. But it still seems kind of sad, I guess, to try to pursue this. But let's do it anyways, and we can see if maybe a better idea comes out. So let's do that. First up is we have to pick a starting location. And to do that, we're literally going to say for each key in the map, called map, great. Which key is the name of a city. So we can actually just call this, let's use their terminology, city. And then V is the destinations. Then we can say like traverse, city and destinations. And we're also going to need to pass in the map here. And then here we can say FN traverse, which takes them to city, where that city is just a string. City is a stir. Dests is going to be... No, we don't actually need to do that. We'll just look that up in the map again. So we can do that. And then we also need the map, which is a hash map from stir to hash map of stir to U16. And then we also need to keep like a history, which is going to be our vec of stir. And it's going to be mutable. Actually, it's not really mutable. We're going to have to clone it a bunch, which is a little sad, but I think that's okay. Yeah, I think that's fine. So what do we do here? First of all, we need dests. So the destinations is going to be map at city. And then we need this by reference probably. So we have now the destinations. Then we can say for dests in, or for D in dests. So now D is a city and the weight that it'll cost to get there. We can say, actually, we can also add like a cost here, which is the running sum, which I think should be fine to be 32. And so history here is a default. No, this isn't a default. This is gonna be a vec containing city. No, I take that back. Do I take that back? Do I untake that back? Yeah, I untake that back. This is gonna be a default. And then cost here is gonna be 0. And then here we're gonna say history.push city. So the current place that we're at needs to be added to this list. And now we're gonna have some lifetime issues, of course. Let's call the lifetime of this 1. Okay, I think we just need to add a named lifetime. And really all of these could be static, but that's too much work. So we're gonna just make these all tick A. Yeah, and it's just borrow. Cool. So now, for each destination, we're going to say traverse to dest with map, and then history dot clone so that we can actually, pass it. And then it's going to be cost plus weight so that we like count up our weight. What is cost? Cost is U32, but weight is a U16. So we need to do that. Parameter used here. I mean, is that right? No, that feels wrong. We need to, what do we need to do here? We need to basically keep track of the minimum cost. I mean, this is really like dests.iter.map. So dest and weight. To be this. Dot min. Right, so like we're basically gonna traverse from all of these points, and I have this comment here just so it doesn't collapse because I really don't want it to. We can actually say let cost is this cost. Oh yeah, you're gonna be a little bit annoying about that, aren't you? If I did that, it's gonna collapse, and I don't want it to collapse, so we're gonna just leave that comment there, even though it's kind of sad. I don't want it to collapse because I'm almost certain we're gonna have to change this, and it just becomes a little bit annoying if it collapses this block. Okay. And we don't want min here, we want that. Mismatch types, expected U32, found option U32. I think it's okay to unwrap here. There are worse things we could do. So let's debug city and cost. Cost is annoying here. What do you want? Parameter is only used in recursion. Yeah. Why did you open there? Oh, you can't do that, can you? That is the Clippy warning. Why is this bad? It can contain a useless calculation, make the function simpler. The argument could be involved in oh, right. This needs to be unwrap or cost. There. So now if we don't have any other cities to get to, then we just return the cost that we're currently at. That is fine. Now let's cargo run this. Stack Overflow. Okay, fantastic. That means that we have an issue. Oh, we're not filtering whether we've already visited a place. So one thing I would like to do is replace this with a hash set because we don't care about the order in its current state. And that means that we can say filter the destination with history contains destination with not contains destination. So we only visit places that we haven't visited. Really? D is, oh, what the hell is that type? That's awful. D is a referencer. Can I copy this? Does that help? Wait, why can't you? Oh, because the tuples are. Yeah, it returns references to the values inside of the tuples, not references to a tuple. It's fine. Yeah, referencer. That's such a great type. Very rare to actually have to do a double dereference in Rust, but here we are. Okay, so with this, we get line 48 to do. Great. So from London, our cheapest is 605. I agree. From Dublin, our cheapest is 659. So we either have 659 or 982. From Belfast, our cheapest should be 605. Cool. What if we run this on the real input? What is this, day 09? I want to change this. I want to do if config debug input. No, not debug input, debug assert. Then I want to do this. I guess let's do let path is so if we're in debug assert, do that. Otherwise, do that. Debug assertions, correct. That's what I want. And then here we'll pass in path. And so now if I run in debug mode, it'll use the example input. If I run in release mode, it'll use the proper input. And that way we just only run the proper input on like good input, or on what's the word? We only run in release mode on the real input. Okay, that was, oh no. Wait, why do we have a map here? Oh, are we printing the map afterwards? Yeah, we are. That was surprisingly fast. I'm like actually really surprised with how fast that was. But okay. So let's do map.keys.map. Basically the same thing we did here. .min. And then I guess it was probably really fast because we're not actually like keeping track of anything more than like a number. We're also keeping a history, but the history is fairly minimal. So I guess it doesn't really do a whole lot. So we can do this, expected that, we can unwrap, and you can be this, and I guess we'll let it collapse. City here is city, and this is not that, this is just that. Cool. Number is very wrong. What if we run on, oh, actually number might not be wrong. I want to run this again, just in normal mode. We get 605, which is correct. I also want to say let cost is this, and then I want to, just for sake of sanity, I want to println city is this, cost is this. Expected U32, found that. Right, we need to return the cost. Okay, so here we get, so from Faerun we get 117. That seems remarkably low. Let's look at this for a minute. So the input day 9 example.txt, or not example, but the real input.txt. I mean, we do have like Faerun to Alpha Centauri is 3. So there are some small numbers. I really just, I feel like it's wrong because there are some really big numbers too. You know what? YOLO. So at 117. Hey, that's correct. Very nice. Let's see. Is there anything else that we can just kind of quickly clean up? I guess let's change this to be 117. Let me add this to the template actually while I'm thinking about it. And then yeah, this parsing might be a little bit slow. Actually, the parsing itself is probably completely fine. It doesn't do a whole lot. Honestly, most of this is pretty fast. Yeah. Okay, that's cool. That seems to be working really fast, actually. Even if we time it, what do we get? Like 50 milliseconds. Okay. Santa decides to take the route with the longest distance instead. Of course he does. That seems very efficient. Good job, Santa. If we just literally paste this in part 2, and then find everywhere where we have it called min, and we instead call max. So if we run this Dublin to London to Belfast, gives us that. If we run this on there, we get left is 605. So we're wrong here. Which is interesting. Oh, no. We're wrong for part 1. We have to comment out part 1. So 982. That's correct. Okay. So now let's run it on our real input. Let's see. Release. That's the word I'm looking for. Bam. So we get 909. Okay, perfect. So that was actually really easy. Now let's see what we can do to optimize it, and let's start a timer. 10 minutes, and let's go. Okay. First of all, let's get a baseline. So let's hyperfind this guy. We're gonna run it. So it's what, or it should be about 100 milliseconds. So let's run it 100 times. Warm up is like 5 times. Day 9, and then day 9. Command terminated. Great. Cargo R bin day 9. Oh, because our assertion is wrong. So this is still 909. Okay. So we're getting about 34.9 milliseconds. That's interesting. Why is it so much lower than it was? Like, I thought when we ran this before, we got 65 milliseconds. Why is this one going so much faster? Did I mess this up somehow? Like this, like the cargo process itself is not running anything. Why is it? I'm so confused. Why is this 65 here, but not here? What if I do time target release day 9? We get 35. I'm so confused. Why is it 30 milliseconds slower like that? It's the same input. Although it is interesting to see that the order, like the output order is different. Which, I mean, I guess... So the default hasher is like a random hasher, random state hasher in a hash map. So it's not surprising that it's not consistent. I just didn't realize it would be actually different between runs. But okay. So this one is regularly like this, but if I cargo R release, it isn't. What happens if I run that one? So cargo target release day 9. So cargo itself is taking 30 milliseconds. That's interesting. Whatever. Tangent. So I mean, honestly, this is already really fast. I mean, we can try perf recording this, but it still does take just a millisecond, or it takes what, 35 milliseconds. So it's not gonna, yeah, it woke up 7 times. So we're really not gonna have a whole lot of stuff in here. Most of it's happening in a hash, like hashing the keys, I guess. We might be able to replace that with like bytes. I don't know that bytes are going to be any better for hashing. I suspect that the hash on stir is going to just treat it as a slice. Let's see. This primitive. If we go look at impl hasher for, or not hasher, but hash, I guess. Let's see, impl hash for stir. So, state.write stir. Interesting. Maybe let's try doing bytes. First of all, let's say day 9. Just to make sure that we have something to go back to if we fuck it all up. Let's see. Let's literally just replace everything that is refster with... No, that's actually not going to work. So you're going to be U8 slice. You're a U8 slice. You're a U8 slice. You're a U8 slice. You're a U8 slice. Everyone's a U8 slice. I feel like a U8 slice sometimes. So much stuff. There we go. Okay. This is now we're gonna have a bunch of issues because specifically here we're gonna have a bunch of issues, and here we're gonna have a bunch of issues. So this is, oh, I kind of forgot that we had these prints. That's obviously gonna not be great. So let's get this back to working. So source here is a stir. That's fine. We can just dot. I guess let's dot 2 bytes here, or as bytes. Same thing here. And here as well. As bytes and as bytes, because bytes are obviously more efficient. Okay. Oh, because we removed the print line. That's fine. Get rid of that. Get rid of that. And then now, it's gonna be kind of hard to tell if this is faster. Oh, I'm actually really surprised that it's not significantly faster already. Purely because we removed the print lines. There's a bunch of stuff in here. I don't care about any of that. Let's do this. Let's see. What did we change? So we replaced stir with slice, which doesn't really seem to have made any impact. I can't say I'm super surprised. And we removed some print lines. Let's do this. Let's say get stash. Let's run this again. Yeah, so we get basically the same time. We save about a millisecond, or half a millisecond. If we were just remove the print lines, what do we save? It doesn't seem to change anything. Like, it's technically running slightly slower, but I think that's just like chance, really. Let's do a little bit more warm up. But also, yeah, that doesn't really change anything. That's kind of surprising, but okay. What happens if we remove this? So skip is not going to work. We just have to say next. I don't think this parsing is really terribly costly, but actually, no, I guarantee it's not costly. So a bigger thing that we could potentially remove is... So this map, we do not use like a map. Right, this doesn't need to do any hashing. This can literally just be a vec of pairs like we were initially talking. Yeah, and then we need to reference here and remove that deref. Cool. Because we're only, like the only thing we ever do with this is iterate over it. So it's kind of fine to just do it this way. And then this is going to take, right, so then we need to change our parsing here to be insert or push this pair, push this pair, and this is going to be back to a vec, like that. And then the same thing up here. It is a little bit annoying that we have our parsing duplicated. Let's actually fix that. That's fine. So let mut map is parse input. What the hell? And then we can move this to be, yeah. Parse input is a stir. And it's going to return this hash map where we have stir and U16. And then I think we don't need to specify the type here anymore. No, we do. Never mind. Okay. That's fine. Then let map equals parse, and we need that same line down here. And I guess map doesn't need to be mutable anymore. Okay. Arguments of this function are incorrect, right? Because now this expects a vec of pair. And I guess fine, we can let that collapse. That one too. Great. Now, let's benchmark. Yeah, so that might have saved us like 2 milliseconds, maybe 3. So it's slightly better. What else can we change? So this map is interesting. Oh, that's our timer. Let's take just a minute, see if we can replace this map. So, I mean, conceivably we could replace it with like a vector. Do we actually need to do any sort of like lookup in here? How do we iterate over it? So dests is basically just this. No, we'd need to look up. So I think a hash map is still our best bet there. That's fine. Anything else that immediately stands out? I don't think so. I mean, we can do it with capacity here. And I guess it has to be a vec now. Vec with capacity. I don't know, probably like 5, maybe 10. Or not a vec, but I guess a hash set. Same thing down here. And the paths aren't terribly long, so this can be fairly small. Another thing is cloning here will like only use the size of the hash set, not the capacity. I don't know if there's like a way to clone with capacity, but that would be something interesting to try. But I don't know that that allocation is really too important. Ooh. You know, considering how much that improved, I want to try doing that. So let's create a clone with capacity, which takes a hash map. It literally takes the set, and that's it. Hash set, and we can even make it generic because we're super cool. And it returns a hash set of t by reference. So we need to do set dot, and I guess t needs to be clone. So we're gonna say new is hash set new, or with capacity. Set dot with, or set dot capacity, right? And then we're gonna say set dot, can I clone into? Uses borrowed data to replace own data, usually by cloning. I don't know that clone into is gonna work with keeping the capacity, but we're about to find out. So yeah, and then we need to return new. Can I see the implementation? So it calls clone from, which is, it just sets. Okay, that's great. If I look at the hash map, or I guess this is a hash set, but a hash set is just a hash map where value is unit, so this is fine. It's totally possible that they could preserve capacity. I just want to see if they do. Target clone from. Self.base.clone from. Okay, this is too much to actually, I think, dig into. but let's run it. So we're getting about that same 28. It is technically slightly faster than before. Oh, we're not even fucking calling this function. So let's call it. This takes it by reference. Then this one does the same thing. Like that. Yep, doesn't seem to have changed anything at all. Maybe ever so slightly faster. Let's... No, I don't have the old one saved, so that's fine. We'll keep it, because why not? Or actually, no, you know what? Let's try this. Let's say set for each... new... Or... It's kind of weird, because if we take, like this T, and we say new insert T clone, there's no guarantee, like this is probably slower than what the actual clone on a hash set does, because this has to do the hashing again, and I don't know that ew, come on. I don't know for a fact that... What am I saying? I don't know that a hash set clone needs to do that. Yeah, that's actually significantly slower, because now it does. It almost certainly, because it has to do the hashing again. Is there like an unsafe method or something for me getting the inner? No, I don't. Okay, I don't think it's worth trying to do this. That's fine. Let's just undo all of this. Cool. So we're about 28 milliseconds. Yeah, I think that's fine. Let us move on. So copy template into day 10. Or, oh, actually, let's also just commit these changes. So what are we changing here? First of all, we're using a vec instead of a hash map. Is that the only change we made? Kind of looks like it. Okay, that's fine. Use vec. Sure. Instead of hash map. A, B. And this is for day 9. We can go ahead and push those. And then let's work on day 10. So in the cargo toml, we can add day 10. And in the day, the input, let's add day 10. And close that, and close, or actually let's grab the input number. That's not at all daunting. Very small number. Okay, so yeah, now we're on day 10. Let's read this. Day 10, elves look, elves say. Today the elves are playing a game called Look and Say. They take turns making sequences by reading aloud the previous sequence and using that reading as the next sequence. For example, 211 is read as 1 2 2 1s, which becomes 1 2 2 1. Okay. Look and say sequences are generated iteratively, using the previous value as input for the next step. For each step, take the previous value and replace each run of digits, like 111, with the number of digits followed by the digit itself. Okay. So 1 becomes 1 1, 1 1 becomes 2 1. 2 1 becomes 1 2 1 1. Okay, so that makes sense. Starting with the digits in your puzzle input, apply this process 40 times. What is the length of the result? So the most straightforward thought would be to literally just have a string or like a sequence of bytes or something, whatever, it doesn't really matter, and then just make it keep getting longer. But I suspect, I already closed the input. I suspect that for a string like this, it would very, very, very quickly grow. Like actually, if we were to just do it manually for like one step, we go from here, we get 3 1, 1 3, 3 2, 2 1, 1 3. So it doesn't change at all. But then we get 1 3, 2 1, 2 3, 2 2, 2 1, 1 3, and we've already grown. And then from here, I think we're just going to continuously grow. We might shrink a little bit from time to time, but it's generally going to be pretty rapid expansion. So I feel like there's probably a better way to do this than just keep a string, because I feel like it'll get really, really big. But it's also not immediately clear to me what that method is. And I suspect, based on the history with Advent, we're going to start with 40 times for this, but then for part 2, I suspect it goes up to like 1,000. And for the record, I have done this before, but I don't remember it. I think I did it like 5 or 6 years ago, and I really do not remember doing it. So I don't actually know for a fact that that's what part 2 does, but I've done enough Advent for this. RLE game. Yeah, this is basically run length encoding, except it just gets worse and worse over time. So let's see. Do we have a good way to do this? I mean, we can see that this pattern here of 1 becomes 1 1, eventually becomes 2 1, and then we know that 2 1 becomes this, and then we notice that there's a bit of a repeat here. So we know that this 2 1 becomes that, and then we know that this 2 1 becomes something else. Honestly, I don't really see of a better way to do this. So let's do it the naive approach, and we can maybe come up with some better approach in a bit. But for now, let's do what we have. Also, let's add input. Hello, auto completion. Okay, day 10 example. And so we're going to start off with, I guess, just 1. Great. So we're not going to parse it as a number because that's kind of unnecessary. Let's see. So input is a number, or input is a string. So let mut next is string new. And obviously we could do like with capacity and stuff, but I don't think it matters for now. Yeah. Okay, so how are we going to do this? So what we need to do is we need to strip, like, or we need to take however many repeating digits we have at the beginning. And so one way is just to loop over characters and count until you have a change in character. Another way is to like actually look ahead and find the first different character. And I think, let's see, let's go look at the string methods, because there's a bunch of like utility stuff in here. God damn it, I did it again. This is the same thing I did last time. Stir. So we've got, so none of this is really all that. Oh, my microphone just fell. Hold on. Sorry about that. I have slightly changed my setup, and it seems that not everything is quite as stable as I would hope. Anyways, actively panicking. Oh, wait, I'm still on that screen. Yeah, don't panic. It literally says so in the screen. Please stop that. Anyways, where were we? Right, looking at how to get the first different character. So, one thing, we have find, which can take, a character or something like that. And we could take, or I guess this is our find, but we can do that. We can take the first character and use find to, oh, no. You know what we can do? Do we have strip prefix? What does strip prefix look like? So this returns a stir. Returns a string slice with a prefix removed. I wish that this returned the prefix as well. Or I guess there's trim start matches. Where is it? Trim end matches. What? Trim, what? Trim start matches, this. Right, which takes a character and we'll just repeatedly slice it. Yeah, okay, I think this is probably our best bet. So then we get this character by just looking at the first character in the string. And then this returns a stir, which is the rest of the string. So we can say for, or I guess while rest dot is empty. So let mut rest equals input. And now we can say if, or no, we can say rest split. Okay, so this is a bit annoying because we're using strings and we can't just index. Do we have a trim start matches on slices? I don't know if that's actually gonna, yeah, it works. Trim start. No, we don't have a trim start matches. What is a slice pattern? Ugh, go away. Trim start matches. Trim prefix. Oh, it's experimental only, and we're not really doing experimental stuff. Yeah, I don't think we can, sorry, I'm really concerned about my microphone falling again. Which I think it might be, yep, okay, I just did it again. Let me figure out a better solution. I will be back in just a moment. Okay, sorry about that. I think we have a solution that's not gonna just fall down in another like 2 minutes, but we'll see in a couple of minutes. Okay, so yeah, I think we're just gonna stick with stirs for now. Um, it'll be a little bit more pain if we want to switch to integers, or into slices, but I think it's fine for now. Okie dokie. So, we'll just say rest dot chars dot next dot unwrap. Typing is very hard. Okay, so now we have the character that we're looking for, and we can say let next rest is rest dot strip prefix. No, trim start matches. C. And then the length is going to be rest.len minus next rest.len. Mismatch type, to do. And then rest is next rest. Then now in here, next is going to be, what is this? This is going to be push. We need to first of all push the length, which I guess we can just do with right. And then what? Must implement IO, yeah, use stood IO right. Maybe format. And then this can't fail, but we'll unwrap anyways. Saw a panda in your editor. Did you? Where did you see a panda? That's weird. Okay, so we're gonna write the string in your inline LSP. Really? Now I'm really confused because certainly nothing intentional. I don't know if something is like, hey, we're gonna put a panda there for fun. Okay, so we're gonna write this and then we'll write the character. And then let's just debug next. And I guess debug input. Or I guess probably rest. Cannot find value rest in scope. Correct. So let's run this in debug mode on day 10. So we go from 1 to 1, 1. Okay. That's correct. Now let's do a for loop. So for let mut current is, I think we can just do string from input. Some number in, I don't know, 4. It's supposed to be 40, but for now I just want to do 4. Rest is going to be input. Where's the syntax error? Okay, there's none. Rest is going to be input. No, rest is going to be current. And then current is going to become next at the end. Clone, and then next is going to be... No, current is going to be standard mem take next. Perfect. And then that will just replace it with the empty string. No, actually I take that back. That's a bad idea because then you have capacity. Next, current is next, and then next dot clear, which is kind of also bad. We can do Fuck, there's a decent way to do this, but I don't know what it is. Current, clear, current, push, stir, next. Will at least produce allocations. Okay, and then we need to ePrint line, or I guess debug is fine. Current, and then next. Both by reference, of course. No, that. So we get 1, then 1, 1. Then we get 1, 1 goes to 2, 1. And 2, 1 goes to 1, 2, 1, 1. And then we ultimately end up after 4 with 1, 1, 1, 2, 2, 1. Or I guess after, yeah. Then we get to 3, 1, 2, 2, 1, 1. Oh, also a little bit of a hint that we're going to end up with 200 kilobytes of a string, which is honestly not even that bad. Like, in reality, it's not that bad. It's really just the part 2 that I suspect is going to be pretty not great. Okay, so 40. Well, that was really fast. Current.len as that. And then we already know the answer is this. Okay, we are wrong. I think we might be an off by 1 though. We're not an off by 1. Are we an off by 2? What about 3? Okay, no, I think we're just wrong. Oh, well, we're still running in debug mode. Okay, we're good. Still pretty fast, and this includes printing. So what do we get? We get 71 milliseconds. If we remove the printing, it becomes significantly slower. Oh, because it has to rebuild. So we already lost 140 milliseconds like that. So we're about 30. Okay, that's not too bad. That's fine. Yeah, okay. I definitely expected a bit worse. Let's see if we can remove this right. So it doesn't say anything about what to do if you have multiple digits, but I suspect you just write them directly to the thing. That's why I think that the right, or what am I saying? I think it's okay to have multiple digits. I think it's kind of necessary. Although maybe not. If len is less than 10, or sorry, if len is greater than or equal to 10, then we're gonna panic. Which, okay, so that never happens, which means we can then just say next dot push len as u8 plus that. And then we need char from. Which saves us like a millisecond, I think. A millisecond or 2. So, not a whole lot, but a little bit. Okay, well, let's see what part 2 is. Oh, it just says 50 times. So we're gonna end up with what, 3 megabytes? Sure. That I think that's fine. And we got the right answer. So 3 megabytes of memory for a single string. That's cool. I definitely like 3 megabytes of memory for a single string. Okay. Let's see. So, I mean, this is really, let's do a quick hyperfind on day 10. Let me wrap this in a function. So function hyperfind. What does a fish function look like? It's like this, and then it's gonna be argv0, or no, argv1. And then here we're going to do argv1. The only issue that I have here is that I do want to, I want to be able to change this. So actually, because of that, I don't care enough to try to make this a fish function, or like an actual function. That's fine. We'll do this. Let's see, day 10, and then, well, that should be fine. So we're getting at 31 milliseconds. Again, I don't think perf is going to do a whole lot here. Nope. I don't think perf is going to do a whole lot here. Here. Yeah, 4 times. This isn't really going to give us any sort of information. Obviously, time is spent in main. Time is spent in main. Go away. That. Part 2 takes more time. Shocking. Trim start matches takes a long amount of time. And the string push takes time because it needs to reallocate. Yeah. So we could, I think, pretty easily get around this with current.reserve. Like we can, if we just assume that we need, I guess, 4 million bytes. And then we can do with capacity 4 million here as well. And then technically this one could be smaller, but it doesn't matter. With capacity, and then we say current dot reserve 4 million. Then I think this will end up being just a little bit faster. Yeah. So just pre-reserving all of that memory is beneficial. Although I feel like it's a little bit cheaty because we do know what the size is. But it's fine. We can keep it. Why not? We're basically just saying allocate 4 megabytes for this string, which is a scarily large amount of memory for a fucking string, but that's fine. Oh, we did not start a timer. 5 minutes. Okay, what else? So it said trim start matches took a little bit of time. Of course, I have to turn off my bar because it gets annoying. Trim start matches. Can we improve this at all? On here, let's do it in part 2. Okay, you know what? Let's do this. Let's say commit day 10. And then in here, let's do that other option that I was talking about where we keep track of which character we're on. And if we change characters, then we push the new total. So we're going to say let mut run is 0. And then let mut, I guess, C char for current character. And that's going to just be, it's really none. No, we'll say run is 1. And we'll say, this is going to be bytes at 0. And we'll say bytes is going to be current.as bytes. So while, I guess this is 4B in bytes. CB for current byte. Go away. If B equals the current byte, then we're going to just say run plus equals 1. Otherwise, so B here is like that. Otherwise, we're going to run this. And we're going to push B, but char from B. And the length here is going to be run. Char from reference U8 is not a thing. That's fine. In fact, let's do that. CB needs to be updated here. So CB So we're going to push CB, and then we're going to say CB equals B. And run equals 1. And then finally, we have to do that again at the end of the loop. Like that. And then that might be slightly faster, depending on how the trim start is implemented. Cargo R release day 10. So now the implementation is broken. If we do the debug, what do we get? And then here, if we bring back the debug, current, and next. Both by reference, of course. And we're still on release. And I guess we don't need to actually go to 40. Let's do 4. So 1 goes to 2, 1. That's wrong, right? It should be 1 goes to 1, 1. Okay. So why is that wrong? Oh, because this needs to be bytes from 1 and onwards. Because we're already counting the first byte. Yeah, that looks more correct. Okay, so if we remove this debug and we remove, or we reset this back to 40, what do we get? In release mode. Okay, we get the correct stuff. And then if we hyperfind this again, what do we get? Okay, that actually helped quite a bit. And there's two sides of this. So one side is that we're no longer doing that trim start matches, which might have been slightly inefficient, but we're also no longer using character comparisons. We're doing byte-wise comparisons. So that's potentially better as well. On that note, we could also probably replace the string with a vec. And it might be a little bit better here as well. Now we don't need to do char from, we can just use that. And then here, let's also do input dot into or I guess dot as bytes dot to vec. And yeah, now this is going to be back to U8s. And then push stir is going to be extend. Same thing here. So we're going to replace this with vec, this with vec. This is going to be current as, or no, this is going to be input.asBytes.toVec. This is going to be that. This is going to be that. This is going to be that and that. And then this is going to be extend. Extend. Fantastic. And then this might even be a little bit faster. Yeah, we saved another couple of milliseconds. Cool. Anything else that immediately stands out? Not really. Let's do one more quick. Not this. Let's do a perf record on this guy. Yeah, again, just woken up 3 times is not enough to get any good data. Perf report dash G. No. Pushing into a vec is taking the most time. We're literally writing with a pointer is taking the most time. So I'm gonna say that's pretty much as fast as we can get. Pointer writes taking time is kind of crazy. Really the better thing would be to try to optimize for caching and stuff, or for I guess not for caching, but for the cache. But I think from here we're fine, and we're out of time anyways. So let's move on to day 11. Or I guess let's also add day 10. Day 10 performance. Okay, and let's open day 11. I guess input day 11.txt and grab the input for day 11. Short string. Okay. Let's grab the example. So input to day 11 example. Oop, not day 1, day 11. Day 11 not found. What? Oh. Let's see. Do you have... Oh, it doesn't have... Oh, it does have an example. Okay. In the day 11. Before we do this, let's take like a... what time is it? So it's... yeah, let's take a 3-minute break and be right back. If I can figure out where the button is. Be right back. And we're back. Would you ever do a stream entirely in German? I mean, I would consider it, but my German skills are nowhere near good enough, I think, to do an entire stream in German. So there would be a lot of silence. Okay, so day 11. Let's see. Santa's previous password expired and he needs help choosing a new one. To help him remember his new password after the old one expires, Santa has devised a method of coming up with a password based on a previous one. Corporate policy dictates that the password must be exactly 8 lowercase letters for security reasons. That sounds like the opposite of security. So he finds his new password by incrementing his old password string repeatedly until it is valid. Honestly, it sounds like he just needs a password manager. Incrementing is just like counting with numbers. X, X, XY, XZ, YA, YB. Yeah, great. Increase the rightmost letter one step. If it was a Z, it wraps to A, and repeat with the next letter to the left until one doesn't wrap around. Great. Unfortunately for Santa, his new security elf recently started and has imposed some additional password requirements. Okay, so there's some requirements. I haven't read them yet, but what should his next password be? So basically just increment until we meet all of these requirements. Passwords must include one increasing straight, passwords must include one increasing straight of at least 3 letters like ABC, BCD, CDE, and so on, up to XYZ. They cannot skip letters. ABD does not count. Passwords may not contain the letters IOL, as these letters can be mistaken for other characters and are therefore confusing. Passwords must contain at least 2 different non-overlapping pairs of letters. These are some really bad requirements. Anyways, so we take input, which is our current, you're gonna be annoying, aren't you? There. So we take input, which is our current password. Why are you not, oh, because we need to add it to the DOML. Like so. Okay. Are you gonna be happy now? You're not. Okay. So to do part 1. So current password. We basically need a method of incrementing a string. Yeah, so we're gonna say let input is input.toString, just so we can mutate it, or into, and then we'll do a string, just so we can implement it, or increment it, and we'll make this mutable. And since we know that we only ever have 8 bytes, it's okay for us to just do, I'll basically want to have an increment method, increment, god damn, that takes mute input. Then we're going to say fn increment. Okay, I'm not going to be able to spell that. Increment takes in a mutable stir, and it's going to return nothing. So now what? What are we doing in here? So first of all, we're going to say for every character in s.reversed iter.rev, or I guess s.chars.reverse. So walking from the back, we're going to also have like a let mute carry is false. Then we're going to match on this character. If we get a Z, then we're going to get, what are we going to do? So this actually needs to be char, we can't do chars mute. I guess, can we do bytes mute? We can do as bytes mute. I think it might just be worth, immediately going for ubaits just so we can mutate them. Iter mute. Byte, and this needs to be dereferenced. So if this is the case, then we're going to say B is A, and carry is true. And then everything else is going to say, I guess not B, but C. B is, or just B plus equals 1 is fine. And this is also B. So if we get A through Y, then we're just going to count up. But then if we get Z, then we're going to reset to A and set our carry flag. And then now we have to deal with what the carry is. So if we get a Y, if carry, then we're going to say B is going to be A, and carry is true. And this is if not carry. And then if we do carry and we have... I think this condition is being... or is going to be a little verbose, but I think that's okay. So if we carry... Okay, so... I'm getting confused already. If we have A, B, C, and then we end with a Z, and we're not carrying... Or actually, let's do that. So we go to D, and then this goes to A, and we are carrying, which means that this goes to C. Oh, wait, no, yeah, that's just how that works. Wait, hold on. We only need to continue if we are carrying. If we're not carrying, then we're done. Can I do take while carry? No, I can't. That would be kind of nice. If carry... No, that's wrong too. Wait. I've confused myself. That's not good. Okay, so if we have... Okay, let's actually do it this way. Let's say S last mute. No, because that requires bounce checking. No, that's fine. Unwrap. Let last is this. So this gives us a mutable reference to last. Match on the last. Basically, if we get Z, then we're going to say we're going to continue. Basically, we're going to try on the second to last one. Which is interesting because we could make this recursive. Yeah, you know what? Let's do that. There's not really any reason to, I think. But that's fine. So from the beginning to s.len -1 as a mutable reference. And I think we have to reborrow that. Or maybe we don't. And then everything else is going to be this case again. And then this is just B, I guess. Right, so we need to say len is s.len. ct.len. Okay, now we don't care about carry. And all of that should be fine. It's probably not great to have it recursive, but that's fine. I mean, ideally we'd use something like become, but that's not a thing yet. This can be a back of U8. I don't know if that's okay. Okay, it is. Cargo R bin day 11. Not implemented part 1. Right, debug input. Standard stir from UTF-8. Input dot unwrap. HIJKLM whatever. MMN goes to MMO. NOP. Yeah, okay, so that's correct. What happens if we just like do that? Something wrong. So it does increment the next one, but it doesn't set the current one to 0. Oh, which makes sense because, or to A, not 0. Last equals A. Great. I feel like that's correct. N, O, P, Q, R, S, T, U, V, W, X, Y, Z, A, and then the next one increments. So like if we were to just try this instead of on this input, we said let input equals A. It doesn't actually matter how long it is. We support everything. We end up with like, yeah, it seems to be counted correctly. Cool. Perfect. Beautiful. Now we basically just say keep going. And then we check each of these. So how do we check this? I mean, in reality, can we do an array of strings? I think I like ask that like every time, but is that a valid pattern? Contains accepts a pattern. Does it accept an array of strings? It does not. Okay, never mind then. I guess we can walk it and check the next 3 bytes and see if they're all in ascending order. Do we have input like Windows? Wait, so is it what? It must contain? Must include one increasing straight of at least 3 letters. So any A, B, C. Oh, but that's not irrefutable, so we can't actually do that. X. This is a bit annoying. Do we have a Windows exact? No, I don't think so. Basically x0 equals x0, or wait, equals x0 plus 1 equals x1, and x1 plus 1 equals x2. Right, so the first one plus 1 equals the second one, and then the second one plus 1 equals the third one. So if this, then we're going to break. No, then we're going to continue. If not any of them do that, then we're going to continue. Passwords may not contain the letters IOL. So if input contains IOL. Oh wait, we're not on stirs, we're on slices. Search slice. What does contains look like on here? Oh, it just looks for a T. Yeah, I don't think we can do that any better. So we'll just say if input contains I or input contains O. Wait, what was it? IOL. Input contains L. And I think we have another way to improve this by just basically changing this to do 1 iteration. But it's fine. Continue. Right, and these are references to bytes. Like so. Wow, that's really slow. And then finally, passwords must contain at least 2 different non-overlapping pairs of letters. at least 2 different non-overlapping pairs of letters. What does 2 different mean here? Do they have to be different letters? It doesn't really seem like it. So if input So I guess first of all, let's just say input dot windows 2 dot for each. I guess let's just filter L0 equals L1. And then I just want to collect it. I want to pairs just to debug it. Or yeah, to print it. So 979797. So those are the A's. And yeah, we have 3 pairs. But it also doesn't say that that's okay. Oh wait, this is password like verification. Hi Baby Yoda, welcome to the stream. Yeah, does it give me like a good input? Oh, next password after this. Thank you, I shall use that. Input day 11 example.txt. So A, B, C, D, E, F, G, J. Let's just say if pairs dot is empty, then we're gonna continue. Continue. So 104 that's octal, is H. So in this case, H is a pair. So that's correct. But we need 2 pairs. The biggest problem right now is that, like, I guess if pairs len pairs length is 2, and we will obviously replace it with like count or something if this works, but sorry, not equals 2. Biggest problem here is this exact case is we're not like we don't take into account whether we need to skip a pair. You're enjoying Rust? Yes, I love Rust. Rust is probably my favorite programming language. I've been using it for many years now, but it's just great. I use it for basically everything at this point. Well, I say basically everything. I use it for everything important. Okay, so let's say for what are we gonna say here? For every character, let's do this the boring way. For I in 0 to input.len -1. If no, I think we actually literally need this to be like a while loop. If input at I equals input at I plus 1, then what? pairs just plus equals 1. Otherwise, and then I plus equals 1 as well. Otherwise, we do nothing. So I guess really even better would be I plus equals 2, or plus equals 1, and plus equals 2 here. And then if pairs is 1 here, then we can just go ahead and break. No, if pairs is 2, then we can break. And then if we don't have 2 pairs, then we can just try again. And this is obviously very slow, so I think maybe we have some good candidates for optimization. Although I bet, like right now, it's just spinning. Okay, well, OBS is consuming stuff. Oh, we're on memory. CPU. Day 11 is consuming all of the memory in the, or all of the CPU in the world. It's probably, yeah, it's probably just chewing up this one thread. So I think maybe it's wrong. If input is this, let's just debug, or ePrintline missed. This is what we're expecting, but possible that so we already missed it, which is interesting. That means that this check is probably wrong. So if input I is duh. Okay, so we got it. That's cool. That's good. We got it really, really quickly too. Okay, now let's run it on the real input. We get HEP XXYZZ. So that's correct. Very nice. This can just be return standard stir from UTF-8 input.unwrap. And technically we could do unchecked here. Oh, this is not really a stir. This is probably more of a string. Do we have a good way to, I guess we could let's just return a string, and then this can be string from UTF-8 over input. And like we can do unchecked here. It's not going to matter because this literally runs one time. But we can do it like that. Panic, or I guess unreachable. And then here we would do assert that, and then we actually know that the answer for the second one is this. So we can go ahead and insert there. And then let's grab this solution, paste it for part 2, and go take a look at that. Send as password expire again. What's the next one? So this one's a little bit weird. Do we like somehow pass the previous input, or do we just run it twice? I think we just run it twice. Yeah, let's just run it twice. Let's remove this debug too. Oh, is this still marked to return U32? It is. String. Is part 2 just significantly slower, or did I fuck something up? Oh, I did. Okay. This feels wrong. So let's do a little bit of a debug print, of course. Okay, yeah, so we're doing something wrong. If r equals 1, then we return. Oh, otherwise we need to break. Okay, so we got it, and it's working. Yeah, it's working pretty well, actually. If I do cargo... let's hyperfine. So day 11. Day 11. Let's do 100 warm-ups and 1,000 runs. Okay, so we're about 13 milliseconds. That's pretty good. For sake of benchmarking, let's make this 50. That didn't change. Oh, let's do this. If R is max, then we do this. Bad code. Don't ever do this in production, but it's fine here. Oh yeah, and then the assertions are going to be wrong. That was still really fast. Why was that so fast? That should not have been so fast. Yeah, it's... Okay, we'll run it 100,000 times. That required. Come on. Okay, this one might be a little bit too slow. And no, it's fine. Let's do perf record day 11. So cargo, let's build it. Perf record call graph dwarf day 11. And then perf report -g. I don't really expect a whole lot of interesting stuff in here because it is mostly just like iteration. Yeah, so slice contains 77% is in slice contains, so that's not insignificant. Also the other 17 is in the any, but probably the closure. Yeah, that closure is probably doing quite a bit of work. What is the closure? Any, okay, so the any closure is this guy, which I guess, yeah, that it does some stuff. It's not a terribly complicated one, but it does stuff. Let's change this. Contains doesn't. Right, so we can say input.any or .iter.any. B is, I guess, matches B with I or at O or L. Might be slightly faster. Oh, also I forgot to start a timer. We'll keep it at 10 minutes because we haven't actually gotten into this all too much. Yeah, so let's see if replacing that matches has helped at all. Just a quick timing. We were at 6.95 seconds before. I don't really expect it to be a whole lot different. Oh, it's not insignificant. Let's change max back to 1. Or 2, I guess now. And let's do another hyperfine. And see what we get. So 9.6 milliseconds. Before we were at 16. No, before we were at 12. So that's a bit of an increase, or bit of a, not an increase, but a improvement. What else do we have? So let's do a perf record again. Yeah. Let's do this. And the perf record. And then we will, yeah, and then let's perf report. So let's see here. Yeah, part 2 takes all the work. And then now we have slice any is doing a bunch. And specifically iteration. That's interesting. Oh, I guess because we're... I mean, most of the work is done in, like, the closure, which is not terribly surprising. How do I annotate? I don't ever remember how to use this. Annotate current symbol. No symbols found. Great. Yeah, I honestly don't remember how to use perf. That's really annoying. Here's a question. We're taking long enough. Can we do cargo flame graph? Flame graphs are nice. They look nice. Okay. If I open the flame graph. Ooh, that's bright. Sorry about that. How does zooming in work? Zooming in doesn't really work. Okay. So in part 2, yeah, it just gives us the closure. It doesn't actually give us anything within the closure, which isn't terribly surprising. Interesting. I wonder if we could manually inline this and improve it a little bit. Let's take a look at this implementation. So input, so this iterator, like we could theoretically combine these two iterators. I think. Actually, we could combine all of these iterators, which is interesting. Right? So we could say if I is less than input.len minus 2, then we want to say, I guess let's call this like outer. Outer's a bit weird, but let's call this the main loop. Sure. If input at I plus 1 is not equal to input at I plus 1, or input at I plus 1 is not equal to input, or sorry, I plus 1 plus 1 at I plus 2, wait, this needs to be minus 3, then we're going to continue on main. So that handles this Windows check, basically. Yeah, sure, you can be collapsed, that's fine. That should fix that. And then finally, this iterator, we can do this. Let's say if this should be continue on main. Oh wait, no, if pairs equals 2, then we can break. That's not quite true anymore. So if pairs is not equal to 2, then we're going to do this. And input at, or I guess not even that, but I is less than input len minus 1. And yeah, you can also be collapsed, that's fine. And then finally for this, we can just do if input at I, this guy, oop, if this, then we're going to continue on main as well. Right, so let's walk through this. So we increment our input, and then we're going to loop over every character in the input, or every byte, I guess. If we are within the first n-3, then we check if the current one is one less than the second one, or than the next one, and we check if the next one is one less than the one after it, or it's not. So, I mean, we can, since we're already doing this, let's apply some De Morgans and do this because this is the actual logic that is specified. And then if that's the case, then we're going to continue on main, and so we're going to increment and try again. And then if that's okay, then we're going to check if the current character is one of these. And actually, because of like things, let's move this up here. So we'll check if the current character is one of these, and if that's true, then we're going to skip it and move on to the next one. And then finally, if we haven't already gotten 2 pairs, and we're not at the, we're less than, we still have 1 byte left, at least one byte left. Then we're going to check if the next 2 bytes are the same. If that's the case, then we're going to increment our pairs. This needs to go away. And then I think we're good. So then we can increment the I to skip that one. Oh no, we can't just increment the I. Because now if we increment this I here, then we lose like this check, these checks. So I think let mutt skip is false. And not skip. Skip is true. If skip, or I guess just skip wait. No, we basically want to say if. This is weird. We basically want to say if skip is false. Otherwise, do this. Right? Although, actually, in reality, we can move this in here too. So if we are skipping, then we just clear the skip. Otherwise, we actually do that computation. Wait, collapse nested if. Okay, it could have automatically done that, but I guess not. Great. Now let's what we're still doing the 100,000. Let's just run it. Cargo R release bin day 11. Oh, I need to time it. Time this. I feel like it's worse. I feel like it's broken. Yeah, I'm gonna say it's probably broken. It should not have taken, like, it didn't even finish. Oh, that's our timer for optimizations. That's fine. Let's give this a couple more minutes. I feel like something might be wrong with the skip here. Let's go back to 2. Yeah, it's still failing. So let's do this. Let's copy this and then go back to just the I+1, which will basically just mean that we have too many that are correct. Or not. Maybe something else is broken. Oh wait, I only let it run for 2 seconds. Maybe it just needs a little more time. Okay, no. I think something else is broken. Yeah, that's interesting. I feel like this refactor won't really save much, so I'm actually gonna undo these changes. I don't think it's worth spending too much time on this. That being said, this is definitely an improvement. Except it's still broken. Wait. Maybe I'm just not patient. Okay, I'm just not patient. That's fine. Let's yeah, I think that's fine. I think 4 seconds for it to go through 100,000 is generally pretty good. I don't like this. In fact, it makes me really upset to see this, but I think it's throwaway code, so it doesn't really matter. Like ultimately it really doesn't matter. But it does hurt my heart. Let's add day 11 and push that. Okay, now day 12. Let's copy that, put that there and there. Ooh, that's a lot of input. Ooh. That's really bright. Day 12 is there. Day 12 example.txt. Santa's accounting elves need help balancing the books after a recent order. Unfortunately, their accounting software uses a peculiar storage format. That's where you come in. They have a JSON document which contains a variety of things: arrays, objects, numbers, and strings. Your first job is to simply find all of the numbers throughout the document and add them together. 1, 2, 3, and 2, 4 both have the sum of 6. 3 and 4 minus 1 both have a sum of 3, and so on. I suspect part 2 actually involves parsing the JSON, but for now we'll just do this. Let's just grab this example, I guess. And is this like a line by line format? JSON document which contains a variety of things. Your first input is that. Let's open the input again. No, so these are not lines. These are just, yeah. It's a single, it is a single line. I need to be zoomed in. Like that. Okay. So if we go, let's copy the template to day 12. And then let's open day 12. So first of all, I don't think we need to parse the JSON for this. In fact, I think it'll be slightly easier if we don't. So let's just say input split returns an iterator over substrings of the slice separated by character matched in a pattern. The pattern can be that, a slice of chars, or a function or closure that determines if a character matches. If there are no matches, the full string is returned. So what is there a way to split on multiple characters at once? Meaning, like, if you have x dot 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 y in the comment, and we want to like split on a dot, like that, what does that do? I guess let's go play dot rust rustlang.org. What happens if we do... give me my Vim bindings, please. Vim. Oh, Vimium is conflicting. Exclude on this page. Save changes. Okay. And then I want the horizontal layout. Move this over there. Or don't, whatever. Split internal. I don't want that. I want collect into a vec. So we get X and then blank blank Y, which isn't the end of the world. We can just filter by like not empty. If we go back to stir, what do we get? So we have what kind of split options do we have? Floor chart boundary. I don't need that. Split at mute. Split at checked. I don't want any of these. Split white space. So split white space actually does what I want, in that it will split on multiple white spaces. So you see Mary had is separated. Let me see if the source for this is useful at all. Okay, literally filters not empty. Perfect. That means that is probably the best way to do this. So basically I want to say split, take our character, not that, matches. If it doesn't match 0 through 9 or a dash, and then I want to filter X is empty, so it's not empty. Then we can say let nums is this, and we can just collect those to a vec. Just to check that we're actually parsing everything correctly. Let's see, what does this look like? So cargo R bin day 12. We get 1, 2, 3. So that's correct. What if we run this on the real input? We get what looks to be just a bunch of numbers. So that seems to be done correctly. We can then map x parse into like a U32 unwrap. And I already know we have negative numbers, so maybe at I16. These numbers all seem to be fairly small. Yeah, I don't see anything bigger than like 3 digits. So we'll do an I16. And then we can literally, instead of collecting them, we can just sum. And then debug nums. And then this is going to be collect into an I32. And I guess because of that, let's make this an I32 as well. Like that. So we get 156366, which is the correct answer. Perfect. So this does seem to be very much positive, but nothing actually says that it needs to be. So we'll make these I32s. And then for part 2, we're expecting this number. That's fine. Okay. Uh-oh, the accounting elves have realized that they double counted everything red. Ignore any object which has any property with the value red. Do this only for objects, not arrays. Okay, yeah, so this one will require some JSON parsing, I think. I think it's probably technically possible to do this like just via regular expressions or something. But I don't really want to do that. So, and rather than us parsing our own JSON, let's use, I don't really want to use Surdy, because Surdy is big, bulky, and very heavy machinery, but there is a thing called Mini Surdy by David Tolnay, which is basically Surdy, but lightweight. Oh, Although it does have like serialize and deserialize, which is not something I care about. If we look at crates, is there like a fast JSON? Like ideally we use something super fast, but ultra fast JSON parser that outperforms sturdy JSON by 300%. Okay. Is it good? (108 nanoseconds). That's okay. It doesn't have array support, so that's a no. Fast JSON deserialization and serialization schema-based framework. See, but I don't need proper like decoding. Like I just want generic stuff. I don't need to build a struct. I just need to be able to introspect the JSON. What does this use? Oh, it just uses criterion. And like in reality, our own JSON parser is not that difficult. I just don't want to like do that. A hyperfast Python module for reading, writing JSON data? What? Fast iterable JSON parser. That seems good enough. Cargo add jitter. Okay, cool. Input is this jitter. Do they have a pronunciation guide? I don't see one. Okay. I'm gonna call it jitter because I think that sounds nicer. JSON. How do you parse jitter? New. JSON as bytes. Sure. Do I need to do as bytes? Really? Sure. That's fine. So jitter next object dot unwrap. What is next object? Why does that give name? Oh. I see. You need to know which schema you're expecting. Never mind, this does not work for us. Okay, fine. I don't feel like looking at this anymore. Let's just use Minicerty. Minicerty has a JSON thing. I mean, it's JSON only apparently. But I think that there's just like a built-in JSON thing. Let's pull up the docs.rs. JSON from here, toString from str goes to example. If we look at JSON, is there a JSON? What do you think about this library? Create Labs. What is this? Sure, let's take a look at that. What is this? React is a meta runtime for building domain-specific React execution engines. Reactive execution engines. Declare what should exist using JSX. Check out the AI-powered website generator. Yeah, this doesn't even have like description. I don't know what this means. This means nothing. I'm gonna be honest, I literally can't even tell what this is from the description. Okay, anyways, from stir can do this. Is there a DE? Is there really no like just JSON object? I'm a little bit surprised in that. Maybe we don't use this. Let's instead do... I see. The thing is, I don't want to write my own JSON deserializer for this. I don't think it's worth it. I also don't want to bring in 30 because 30 is like really big, really expensive, and has like a lot of machinery. What is this JSON crate? It has no README, has no dependencies. Well, it can parse apparently into what? Parses into... What code gen does it do? Oh, can it like derive or something? Fuck it, let's try it. Cargo add JSON. JSON parse. Input. Unwrap. Unwrap. Great, we get a JSON value. Match JSON value. Or I guess match JSON. Fill match arms. So if we get null, we do nothing. If we get short, what is short? Is that like Java short? Short. Parses the string slice into another type. What the fuck is short? Object. No, short. Short. A short is a small string up to max len bytes. I don't care about strings. Numbers I care about. Objects I sort of care about. And then arrays I do care about. JSON values dot. And I guess this is actually going to be handle JSON. Takes a JSON, which is a JSON value, and it returns I32. So if we get a number here is a number. Very nice. As fixed point I64 with 0 points into whatever type we need. Dot unwrap. Sure. Boolean we can ignore. Objects are going to be, or let's do this JSON value since I already have this. So we handle JSON, I guess JSON, what is JSON values? Values is a vec. For v in JSON values. Handle JSON v. Add to it, and then we can return the sum. Like that. This object, we're gonna say object dot, what is this? This should be like a hash map probably, except it's an object, of course. Object dot entries values iter for kv in this. Is that correct? It is. If v equals JSON value string red dot into, I assume, return 0. So v here is that. Yeah, and then here, what are we gonna do? So now, in this case, we're gonna say for kv in object.into. I can't do into iter, really? That's fine, we'll do iter mute. And we'll say, let mut sum equals 0. Sum plus equals handle JSON input, no, not input, v standard mem take v. And this might not be okay because it needs default. Replace with JSON value null. Okay, that should work. So we're going to handle JSON on JSON. Okay, so that worked. And we already have this set to be the correct value. Right, so we get 96852, 96852. Perfect. Go away. Everything else seems fine. Let's run this again. It's interesting that building it now takes time. Let's open the toml. We can remove this jitter. I don't know. Both seem wrong. And then let's do a quick hyperfine. There's not going to be a whole lot we can improve here purely because we're using libraries. Like for that JSON, we're already using a library, so there's not really much that we can update. But we're still sub milliseconds, so I'm going to consider that a win. Okay. With that, I think we're gonna call that done for today. So thank you, or actually, you know what? We're gonna push. I forgot to do that. And here is the repository. That guy. And with that, we're definitely gonna wrap it up for today. So thank you everybody for coming, and I will see you next time.